Welcome back to another journey through the irradiated corporate ruins of the Fallout universe, where tonight we're wandering through the manufacturing floors and executive suites of pre-war America's robotics giants. We'll be examining the corporate structures, production specifications, and automated legacies of RobCo Industries and General Atomics International, the two companies that built the mechanical armies still walking the wasteland, from household servants to instruments of war, all of them outlasting the civilization that gave them purpose. In the years before the bombs fell, when America still believed in the promise of tomorrow and the hum of atomic power, two corporate titans stood astride the robotics industry like colossi of chrome and ambition. RobCo Industries and General Atomics International weren't merely manufacturers of automated servants and mechanical soldiers. They were architects of a future that would never arrive, builders of a utopia destined to become a graveyard of rust and radiation. The stories of these corporations, etched into every terminal screen, still flickering in the darkness of abandoned facilities, reveal a world where innovation and avarice walked hand in hand down corridors that would soon fill with the screams of nuclear fire. Robert Edwin House sat at the apex of RobCo Industries, a man whose brilliance was matched only by his megalomania, whose vision for humanity's future was inseparable from his own immortality. The organizational structure beneath him was a carefully constructed pyramid of power, with regional vice presidents scattered across what remained of the United States, each one a feudal lord managing their territory's production quotas and military contracts. The board of directors, those men in expensive suits who met in conference rooms overlooking pre-war Las Vegas, believed they held some measure of control over House's empire, unaware that their CEO had already begun preparations that would outlast them by centuries. Terminal entries from RobCo headquarters, still accessible on rusted computers in the Mojave wasteland, reveal the mundane bureaucracy that undergirded technological revolution. Requisition forms for servo motors, complaints about cafeteria food, and encrypted communications about projects that would reshape warfare itself. The acquisition of Repcon Aerospace in the months before October 23, 2077, represented House's final major corporate maneuver before the world ended. What had been an independent aerospace company with dreams of reaching the stars became another subsidiary in the RobCo portfolio, its scientists and engineers absorbed into a structure that valued profit margins as much as innovation. The Pip-Boy division operated with a strange autonomy within RobCo's framework, its engineers focused on the wrist-mounted computers that would become synonymous with vault life, those green, screened devices that measured radiation exposure and cataloged the desperate inventory of survival. The Terminal Division, responsible for the unified operating system that would run on nearly every computer in pre-war America, operated from facilities where programmers worked in shifts to meet military deadlines, their fingers flying across keyboards as they built the digital infrastructure of a civilization's final days. General Atomics International emerged from a different tradition, its roots in the earliest days of nuclear power, when splitting the atom seemed like unlocking heaven rather than summoning hell. The corporate leadership maintained offices in facilities scattered from the capital wasteland to the Commonwealth, each complex a monument to the marriage of atomic energy and consumer convenience. Military liaison departments operated with the kind of security clearance that made even RobCo's classified projects look transparent, their personnel moving between Pentagon briefings and production floors where assembly lines built instruments of pacification and destruction with equal efficiency. The Consumer Products Division pursued a different dream, the promise that nuclear power could do more than destroy, that it could cook dinner, clean houses, and tend gardens with the friendly efficiency of a mechanical butler whose fuel source would outlast human lifespans. The Protectron emerged from this consumer military synthesis, a robot whose modular design philosophy reflected the American love of standardization and mass production. The basic construction model, with its pod-like torso and stubby limbs, could be spotted on building sites across pre-war America, its welding torch leaving bright scars on steel beams while human workers took their government-mandated breaks. Police variants patrolled city streets with a cold mechanical efficiency, their programming matrices loaded with law enforcement protocols that reduced justice to binary code, their arrests carried out with servos designed to restrain without the messy complications of human judgment or mercy. Medical units, painted in antiseptic white with red crosses stenciled across their chest pods, could be found in hospitals where they administered injections with precision that human hands couldn't match, though their bedside manner consisted of pre-recorded reassurances delivered in a voice that made comfort sound like a technical specification. The Fire Brigadier Protectrons stood ready in stations where the smell of diesel and determination once filled the air, their built-in flame retardant systems and emergency protocols making them ideal for situations where human firefighters might hesitate or fall. In the twisted ruins of Nuka World, custom Protectron models still patrol, their chassis painted in the garish colors of corporate branding, their personality matrices corrupted into caricatures of customer service, greeting raiders and survivors with welcome messages designed for tourists who would never come. Subway steward configurations, those patient guardians of underground transit systems, still announce delays and platform changes to tunnels filled with feral ghouls instead of commuters, their voices echoing through darkness where the trains stopped running 2 centuries ago. The personality matrices installed in each Protectron represented thousands of hours of programming, behavioral trees that attempted to reduce complex human interactions to predictable response patterns. Security models growled, threats in voices synthesized to inspire submission, while customer service units maintained a cheerfulness that bordered on the grotesque, their greetings delivered with enthusiasm that never wavered even as their facilities crumbled around them. The modular nature of these matrices meant that a Protectron could transition from construction worker to law enforcement with nothing more than a program update, a flexibility that made them invaluable to a military apparatus planning for total war. General Atomics pursued a different design philosophy with the Mr. Handy line, creating robots that floated rather than walked, their thruster propulsion systems allowing them to navigate stairs and obstacles that would stop their wheeled or tracked competitors. The consumer model, exemplified by units like Codsworth, came programmed with butler protocols that attempted to capture the fine-town essence of English service, their synthetic voices carrying accents that approximated aristocratic refinement, while their flamethrowers and buzzsaws remained discreetly hidden beneath their chassis. These robots could prepare meals from recipes stored in databases that encompassed cuisines from mistas around the world, though the ingredients they worked with grew increasingly ersatz as resource shortages bit deeper into American supply chains in the months before the war. The Miss Nanny variant targeted a different market segment, its programming matrices loaded with childcare protocols and medical knowledge, its voice modulated to project maternal concern rather than the butler's professional distance. These units could be found in wealthy homes where parents outsourced nurturing to machines, and in medical facilities where they tended to patients with a combination of programmed compassion and clinical efficiency that human nurses found either reassuring or deeply unsettling. The military derivative, designated Mr. Gutsy, stripped away any pretense of domestic service. Its personality matrix loaded with drill sergeant aggression and combat protocols. Its armaments upgraded to include plasma weapons and missile launchers that made it a formidable opponent on battlefields where human soldiers were increasingly seen as liability rather than asset. The thruster propulsion system that allowed these robots to hover represented a minor miracle of pre-war engineering, a fusion of atomic power and mechanical ingenuity that consumed fuel at rates that would have been unsustainable in any world not drowning in nuclear energy. The maintenance requirements were extensive. Fuel lines that needed regular inspection, thrust vectoring systems that required calibration, and radiation shielding that degraded over time. Yet hundreds of these units continued operating 2 centuries after their last scheduled service, their atomic batteries still providing power while the civilization that built them moldered in the ruins. The Sentry Bot embodied a different design philosophy entirely, one that prioritized overwhelming firepower and armor protection over the niceties of human interaction or household service. These massive combat platforms rolled on treads designed to traverse rubble and rough terrain, their bulk making them unsuitable for anything except military applications where collateral damage was an acceptable cost of victory. General Atomics secured military contracts worth billions of pre-war dollars to produce these mechanical juggernauts, each unit representing a triumph of engineering and a testament to humanity's capacity to build instruments of destruction. The heavy weapon configurations varied based on military requirements. Some mounted Gatling lasers that could reduce infantry to carbonized silhouettes. Others carried missile launchers loaded with high explosive ordnance that could crack open bunkers or destroy light vehicles. The armor specifications read like something from a tank rather than an infantry support unit. Layered composite plating designed to withstand small arms fire and resist penetration from all but the heaviest anti-armor weapons. The nuclear power sources that drove these machines required shielding that added tons to their already considerable weight. Lead-lined cores that kept operators safe from radiation while providing centuries of operational endurance. Military procurement numbers remained classified even after the bombs fell, but terminal entries from Army logistics centers suggest thousands of these units were deployed to fronts in Alaska and China, where they earned reputations as unstoppable killing machines that continued fighting long after the human soldiers around them had fallen. Specialized variants like the Siege Breaker models represented the bleeding edge of pre-war military robotics, experimental platforms that pushed the boundaries of what automated weapons could achieve. These units carried upgraded weapon systems and reinforced armor, their programming matrices loaded with tactical algorithms that made them capable of independent operation in complex battlefield environments. The few that survived the war continue to patrol the ruins, their identification friend or foe systems long since failed, treating everyone they encounter as hostile targets to be eliminated with extreme prejudice. The Assaultron program emerged from a different tactical requirement, one that recognized the limitations of heavy platforms like the Sentry Bot in urban warfare and close quarters combat. These humanoid robots, sleek and terrible in their efficiency, were designed to close with the enemy at speeds that human soldiers couldn't match. Their melee combat capabilities supplemented by the devastating Dominator head laser system that could reduce targets to ash with sustained fire. The close combat design philosophy prioritized agility over armor, creating machines that could dodge incoming fire while closing to ranges where their blade-like appendages could dismember opponents with surgical precision. If you're still with me after hearing this, hit that like and subscribe button. The stealth field technology integrated into command unit variants represented some of the most sophisticated hardware General Atomics ever produced, cloaking devices that bent light around the Assaultron's frame and rendered it nearly invisible until the moment it struck. These advanced models were reserved for special operations units and corporate security applications where discretion mattered as much as lethality. Modifications like those seen in the Class 0 type demonstrated the platform's adaptability, with custom personalities and weapon loadouts that transformed standard military units into something approaching individual identity. Though whether these modifications represented true personality or simply more sophisticated programming remained a question that philosophers and technicians debated in the years before debate became irrelevant. The head laser system itself drew power directly from the Assaultron's fusion core, channeling energy through focusing lenses that required calibration so precise that military manuals devoted entire chapters to maintenance procedures. The heat generated during sustained fire could warp lesser materials, which necessitated the use of exotic alloys in the laser assembly, materials whose supply chains stretched across the globe to mining operations in countries that would become radioactive glass when the missiles flew. Targeting protocols allowed the Assaultron to track multiple threats simultaneously, its optical sensors feeding data to processors that calculated trajectories and threat assessments in microseconds, making decisions about who would live and who would die with the cold efficiency that only machines could achieve. The Liberty Prime project represented the apotheosis of pre-war military robotics and the nadir of human hubris, a colossus that stood as testament to America's willingness to pour unlimited resources into weapon systems of staggering impracticality. RobCo Industries contributed the software architecture that would animate this mechanical titan, programming teams working in shifts to develop tactical algorithms sophisticated enough to control a 100-foot-tall robot while maintaining the kind of aggressive American patriotism that would make the machine's very existence a propaganda victory. General Atomics provided the weapon systems, those shoulder-mounted nuclear catapults that could reduce city blocks to craters, along with the eye lasers that served as the prime's equivalent of small arms fire, though their destructive capacity exceeded most artillery pieces. The joint military contracts that funded Liberty Prime's development ran into the billions, cost overruns that would have bankrupted smaller nations, but which the United States absorbed with the desperate determination of a civilization that knew it was running out of time. The Mark I prototype, constructed in facilities outside Washington District of Columbia, never achieved full operational status before the bombs fell, technical difficulties, and software incompatibilities, creating delays that frustrated Pentagon officials who saw Chinese forces advancing across Alaska while their super weapon gathered dust in a hangar. The Mark II development phase, initiated in the Commonwealth decades before the war, represented an attempt to learn from the Mark I's failures, incorporating improved power, systems, and more reliable software, though it too would remain incomplete when October 23rd arrived with its payload of nuclear fire. Terminal entries from RobCo programmers assigned to the Liberty Prime project reveal the frustration of trying to make nationalist propaganda function as tactical doctrine, the challenge of teaching a machine to distinguish between acceptable and unacceptable targets while maintaining the kind of jingoistic fervor that military brass demanded. The weapons systems integration proved equally challenging. General Atomics engineers struggling to synchronize nuclear catapults with the walking cycle of a robot whose every step registered on seismographs, whose weight distribution required constant adjustment to prevent the machine from toppling under its own mass. The collaboration between the two corporations was marked by the kind of competitive tension that characterized all pre-war business relationships, each company jealously guarding proprietary technology while being forced to share enough to make the project viable. The Pip-Boy manufacturing process represented a different kind of challenge, one that required miniaturization and reliability rather than overwhelming firepower. RobCo's facilities in Massachusetts produced the Pip-Boy 3000 series on assembly lines where human workers and robots collaborated in an uneasy partnership, quality control technicians testing each unit's radiation, sensors and data storage systems before shipping them to Vault Tech for installation in the underground facilities that would preserve humanity through atomic winter. The Pip-Boy 2000 models, larger and less sophisticated than their successors, found homes in military applications and government offices where their rugged construction and straightforward interface made them ideal for personnel who needed computing power without unnecessary complications. Model differences between the 2000 and 3000 series extended beyond mere size. The 2000 utilized tape-based data storage that required physical media changes, while the 3000 incorporated solid-state memory that could store vast quantities of information without mechanical components prone to failure. Vault Tech contracts specified exact requirements for biometric locks, ensuring that each Pip-Boy would bond to its assigned vault dweller's physiology, making theft or transfer impossible without sophisticated technical knowledge. Military variants stripped away some of the health monitoring features in favor of enhanced communication capabilities and tactical mapping systems, transforming the wrist-mounted computer into a battlefield management tool that could coordinate squad movements and mark artillery targets. The data storage capabilities of the Pip-Boy 3000 series bordered on the miraculous for their time, with memory chips that could hold hundreds of holotapes worth of information, notes and recordings, and radio frequencies, all accessible through the green-screened interface that would become iconic in the wasteland. The biometric integration meant that the device monitored its wearer's vital signs constantly, tracking radiation exposure down to the individual rem, calculating the optimal use of medical supplies, and providing warnings when contamination reached dangerous levels. These features, designed to keep vault dwellers healthy during their underground imprisonment, would prove equally valuable to wasteland wanderers navigating a world where radiation lurked in every puddle and dust mote. The unified operating system that RobCo developed for its terminal network represented an attempt to standardize computing across corporate, government, and military applications, creating a common interface that would allow technicians to move seamlessly between different installations. The development process consumed years and millions of dollars. Programming teams, building security protocols, that would protect sensitive data while maintaining the user-friendly interface that made the terminals accessible to personnel without extensive technical training. Network architectures allowed terminals to communicate across vast distances, relay systems bouncing encrypted signals from coast to coast, creating the digital backbone of pre-war American infrastructure. Security protocols incorporated multiple layers of protection, from simple password authentication to sophisticated encryption algorithms that required quantum computing power to crack. Yet, the system's designers built in vulnerabilities both intentional and accidental. Maintenance programming created backdoors that would allow authorized technicians to bypass security measures during repairs, access points that clever hackers could exploit given enough time and skill. The hacking vulnerabilities that plague wasteland scavengers trying to access locked terminals stem from these design choices. The balance between security and accessibility that pre-war engineers struck, leaving openings that anyone with a Pip-Boy and determination could exploit. Terminal entries across the wasteland preserve fragments of the mundane horror of pre-war life. Office workers complaining about broken coffee machines in facilities where nuclear weapons were assembled, scientists documenting experiments that violated every ethical principle while using language that made atrocity sound like progress. The terminals still functioning 2 centuries after the bombs demonstrate the robust nature of RobCo's hardware, solid-state components, and radiation-hardened circuits continuing to operate in conditions that would destroy lesser technology. The iBot production lines represented General Atomics' venture into lightweight reconnaissance platforms, robots small enough to navigate ventilation systems and urban environments where larger units would struggle. The EID-type specifications called for a spherical body containing sophisticated sensor packages, communication equipment capable of receiving and broadcasting across multiple frequencies, and enough armor to survive small arms fire without becoming too heavy for the hovering propulsion system to lift. Duraframe improvements in later production runs reinforced the chassis against electromagnetic pulse damage, a concern that grew increasingly pressing as international tensions escalated and the threat of nuclear war shifted from abstract possibility to looming certainty. Propaganda broadcasting equipment turned iBots into flying loudspeakers, their speakers capable of projecting messages across city blocks, their memory banks loaded with patriotic appeals and emergency instructions that would play on endless loops even after the audiences they were meant to reach had been reduced to shadows on concrete. Surveillance packages incorporated cameras and audio recording equipment, creating mobile observation posts that could loiter over suspicious locations for hours, feeding data back to command centers where intelligence officers sifted through thousands of hours of footage looking for signs of Chinese infiltration or domestic dissent. The enclave modifications made to iBots after the war demonstrated the platform's adaptability, upgrades that enhanced their communication range and allowed them to serve as relay stations for the remnant government's scattered forces. The Robobrain program emerged from the darkest impulses of pre-war military science, the recognition that human creativity and adaptability could be combined with robotic durability to create soldiers who would never question orders or suffer from post-traumatic stress. The human brain integration process required surgical precision and ethical compromise, extracting living brains from donors, a euphemism that covered everyone from executed criminals to military volunteers who signed contracts without understanding what they were agreeing to, and suspending them in nutrient baths within armored chassis. The military applications were obvious and horrifying, creating units that could think tactically while possessing the armor and weapons loadouts of heavy combat platforms. Criminal brain usage represented a particularly cynical aspect of the program, the theory being that individuals who had already demonstrated willingness to violate social norms might prove more effective in combat situations requiring ruthlessness. Terminal entries from facilities that process these conversions reveal the bureaucratic machinery of atrocity. Requisition forms for cranial, saws, and nutrient solution, maintenance schedules for the tanks where extracted brains waited for installation, and psychological evaluations of subjects trying to determine who would adapt best to their new mechanical existence. The think tank modifications developed at Big Mount pushed the concept even further, creating research platforms where multiple brains could collaborate on scientific problems while their bodies rotted in disposal units, a perversion of academia that reflected the wasteland's capacity to corrupt even the pursuit of knowledge. Robo-Scorpion variants combine the Robobrain concept with biomechanical horror, grafting rad scorpion tails and claws onto robotic frames controlled by human brains, driven mad by their transformation. These abominations stalked the Mojave wasteland as testaments to the depths of scientific depravity, their existence raising questions about the nature of humanity that had no comfortable answers. The preservation technology that kept the brains alive functioned with disturbing efficiency, nutrient pumps cycling fluids that approximated blood electrical stimulation, preventing tissue degradation, creating a kind of immortality that resembled eternal punishment more than transcendence. Corporate espionage between RobCo and General Atomics characterized their relationship as much as collaboration. Industrial spies infiltrating competitor facilities to photograph blueprints and copy software, double agents feeding misinformation designed to lead rivals down technological dead ends. Patent disputes clogged courts with lawsuits that would never be resolved, lawyers arguing over who owned the rights to specific servo designs or targeting algorithms while the world spiraled toward annihilation. Industrial sabotage ranged from subtle, defective components slipped into competitor supply chains to blatant acts of destruction that required corporate security forces to maintain armed presences at sensitive facilities. The pre-war corporate warfare between these titans mirrored the international tensions playing out on the global stage, profit motives and nationalist fervor blending into a toxic amalgam that poisoned decision-making at every level. Technology theft became so commonplace that companies budgeted for it, building espionage costs into project timelines and maintaining counterintelligence divisions whose sole purpose was catching spies and feeding them false information. Terminal entries document bidding wars for military contracts that involved bribery, blackmail, and occasionally more direct forms of persuasion. Pentagon officials receiving gifts that ranged from expensive watches to prototype weapons systems delivered to their homes with no questions asked. If this story has kept you listening this far, and you want more of these dark confessions from the wasteland, hit that like button. It really motivates me to create similar Fallout lores. The post-war automated factories scattered across the wasteland stand as monuments to the hubris of total automation. Production facilities designed to operate without human oversight, their assembly lines still churning out products for markets that no longer exist. The General Atomics Galleria in the Folk Commonwealth preserved a snapshot of pre-war consumer culture frozen in radiation and time. Its Mr. Handy units still attempting to manage stores where merchandise gathered dust for 2 centuries. their customer service protocols demanding they greet visitors who came to scavenge rather than shop. The quality control systems in these facilities continued their programmed functions with mindless dedication, robotic arms testing products against specifications written before the war, rejecting units that failed to meet standards that no longer mattered to anyone except the machines, enforcing them. RobCo's manufacturing complexes, particularly those hidden in secure locations or buried deep enough to survive the initial blasts, maintained production schedules that outlasted their corporate masters by generations. Conveyor belts moved components through assembly stages where robotic welders and installers worked with precision that human hands could never match, building Protectrons and Pip-Boys that would never be delivered to customers who had been vaporized in nuclear fire. The automation protocols governing these facilities accounted for supply chain disruptions and equipment failures, but never contemplated the total collapse of civilization, creating situations where factories would cannibalize their own infrastructure for raw materials, stripping non-essential components to feed assembly lines that could not conceive of stopping. The Mechanist's robot army in the capital wasteland demonstrated what could happen when someone with technical knowledge gained access to these automated production systems, hijacking assembly lines to create mechanical soldiers loyal only to their new master. The ease with which these facilities could be repurposed revealed a fundamental vulnerability in pre-war automation philosophy: the assumption that control systems would remain in authorized hands, that the security protocols protecting factory floors would never be breached by wasteland scavengers with jury-rigged hacking equipment and desperate determination. Robot production continued in facilities across the former United States, assembly lines building units according to specifications designed for a world that no longer existed, their programming unable to adapt to changed circumstances because adaptation had never been considered necessary. The maintenance requirements for keeping these automated factories operational proved less demanding than pre-war engineers anticipated. The robust construction and redundant systems allowing facilities to continue functioning despite years of neglect. Self-diagnostic routines identified failing components and either repaired them using automated systems or worked around the damage, rerouting production through functional sections of assembly lines too large for any single breakdown to halt completely. The radiation that permeated everything actually benefited some systems, the ambient energy providing supplemental power to photovoltaic cells that had been installed as backup systems, but which became primary power sources when grid connections failed. The Sentry Bot production facility, hidden in the former military installation designated Site R, continued, assembling combat platforms decades after the last human engineer walked its floors, quality control terminals still documenting test results for weapon systems and armor integrity. The robots rolling off these lines possessed the same specifications as their pre-war predecessors, down to the nuclear cores that would power them for centuries, and the targeting systems calibrated to engage enemies that no longer fielded organized military forces. Some emerged from storage already obsolete, their friend or foe identification systems looking for transponder codes that no friendly forces broadcast anymore, making every contact a potential hostile engagement. General Atomics Assaultron assembly facilities incorporated particularly sophisticated automation, the complexity of these combat platforms requiring precision that only robotic assembly could achieve consistently. Each unit, underwent testing protocols that simulated combat conditions, laser targeting systems verified against moving targets, melee combat routines executed against crash test dummies that would be reduced to scrap and recycled into the next batch of test subjects. The stealth field generators required calibration so precise that human technicians had struggled with the task even before the war, leading to automation systems that could perform in minutes what would take skilled workers hours. These testing chambers became tombs for the Assaultrons that failed quality control, their components harvested and fed back into production cycles that wasted nothing. The corporate hierarchies that once commanded these industrial empires dissolved in nuclear fire, but the organizational structures they created persisted in terminal databases and automated systems programmed to respect chains of command that no longer existed. Regional vice presidents, whose authority once extended across states, now existed only as access credentials in security systems, their passwords still granting privileges to terminals scattered across the wasteland. Board of directors meeting minutes, preserved in servers that continued running on emergency power, documented debates about quarterly earnings and market share that seemed absurd in retrospect. The concerns of men who thought their biggest problems were stockholder satisfaction and regulatory compliance, blind to the annihilation, rushing toward them. Robert House's preparations for the end demonstrated a level of foresight that separated him from his corporate peers. His understanding that the world's trajectory led inexorably toward nuclear war, driving decisions that seemed paranoid until the bombs proved him right. The defensive systems he installed around New Vegas, the calculations that would bring most missiles down before they could destroy his city, represented the application of RobCo's technological capabilities toward personal survival rather than corporate profit. The Securitrons that would enforce his will across the Mojave were products of the same industrial complex that created the Protectrons, serving Vault-Tec and the military, but House's vision extended beyond quarterly earnings into centuries-long planning that assumed he would outlast the civilization that birthed him. The terminal entries, documenting RobCo's final days before the war, reveal an organization in crisis, supply chain disruptions creating shortages of critical components, military contracts demanding impossible delivery schedules, and workforce morale collapsing as employees recognized the futility of their efforts. Absenteeism reached catastrophic levels in the weeks before October 23rd, workers abandoning their posts to be with families or to pursue last-minute preparations for survival. The automation that had been implemented to reduce labor costs became essential to maintaining any production at all. Assembly lines running with skeleton crews of human supervisors, watching over robots that never called in sick or demanded hazard pay for working with radioactive materials. General Atomics faced similar challenges, though their military liaison departments maintained better discipline through a combination of patriotic appeals and threats of prosecution for desertion. The Consumer Products Division saw mass resignations as engineers and designers concluded that building better robot butlers mattered less than securing shelter and supplies for the coming catastrophe. Terminal correspondence between division heads and corporate leadership preserved arguments about whether to continue civilian production or redirect all resources toward military contracts, debates that were rendered moot when the missiles launched and turned every facility into potential rubble. The Protectron personality matrices underwent their final updates in the days before the war, programmers adding emergency protocols and disaster response routines that anticipated civil unrest and infrastructure collapse but not the total devastation that awaited. These updates included instructions for maintaining order during resource shortages, protocols for crowd control and riot suppression that would see use in the immediate aftermath of the bombs, when survivors gathered at government facilities seeking help that would never arrive. The medical Protectrons received updates to their diagnostic databases, information about treating radiation sickness and blast injuries, practical knowledge that proved invaluable in the hours after detonation when hospitals overflowed with casualties that would overwhelm human medical personnel. The subway steward configurations received their most extensive updates, programming designed to keep transit systems operating during civil defense emergencies, routing passengers to shelters and maintaining order in tunnels that would become tombs when the blasts hit. These updates included calming messages and evacuation procedures, recorded in voices designed to project authority and reassurance, while guiding people through scenarios where neither would matter. The Protectrons, still broadcasting these messages 2 centuries later, serve as haunting reminders of the last desperate attempts to impose order on chaos. Their announcements about service disruptions and alternate routes, echoing through tunnels where the train stopped forever. The Mr. Gutsy variants saw accelerated deployment in the final months before the war. Military planners, recognizing that human casualties in the Sino-American conflict had reached unsustainable levels, and that robotic soldiers offered the promise of victory without the political costs of draft expansion. These combat robots shipped to front lines in Alaska, where they fought against Chinese forces in conditions that would kill human soldiers through exposure alone, their synthetic voices hurling insults and threats in combat situations where psychological warfare mattered less than suppressing fire and holding positions. The aggressive personality matrices installed in these units reflected military culture at its most toxic, drill sergeant stereotypes amplified to caricature and loaded into machines that would never question orders or show mercy. The manufacturing specifications for Mr. Gutsy units prioritized durability and firepower over the customer service features that characterized their civilian counterparts. Armor plating replacing decorative chrome, weapon hardpoints occupying spaces where tool attachments would mount on Mr. Handy models. The thruster systems received upgrades to handle the additional weight, fuel consumption increasing to levels that would have been problematic if not for the abundant atomic power that pre-war America took for granted. Combat testing involved live fire exercises against targets that sometimes included captured Chinese soldiers, terminal entries from testing facilities documenting lethality statistics with the same clinical detachment used to record weather data. The Sentry Bot armor specifications evolved through multiple iterations as battlefield experience revealed weaknesses in earlier designs. Engineers adding ablative layers to disperse energy weapon impacts and reinforcing joints where Chinese anti-materiel rifles had found vulnerabilities. The composite plating incorporated materials whose supply chains stretched across the globe, rare earth elements mined in countries that America's foreign policy had alienated, creating dependencies that military planners worried about in classified briefings, while continuing to build weapons systems that required those same materials. The lead shielding around nuclear cores added protective mass that made Sentry Bots nearly immune to radiation, a feature designed for tactical nuclear warfare scenarios where contaminated battlefields would kill unprotected infantry. The nuclear power sources themselves represented engineering triumphs and environmental catastrophes waiting to happen, miniaturized fusion reactors that would run for centuries without refueling, but which could turn into dirty bombs if their containment failed. Military procurement officers accepted these risks because the alternative, conventional power sources that would require frequent refueling in combat zones, seemed more dangerous than the possibility of reactor breaches. The few Sentry Bots that suffered catastrophic core failures during the war created exclusion zones that remained dangerously radioactive. Generations later, craters where the ground itself became hostile to life. The Siegebreaker variants incorporated experimental weapon systems that pushed the boundaries of what could be mounted on a mobile platform. Heavy plasma cannons that drew so much power they could drain a fusion core in sustained combat. Missile launchers loaded with thermobaric warheads designed to clear fortified positions by consuming all oxygen in confined spaces. The tactical algorithms governing these specialized units allowed for autonomous operation in scenarios where communication with command would be impossible. Decision-making protocols that turned each Siegebreaker into an independent military force capable of adapting to changing battlefield conditions without human oversight. The Assaultron Dominator head laser system underwent constant refinement in the years before the war. Engineers, working to increase beam intensity and reduce cooldown times between firing sequences, pursuing the perfect balance between destructive power and thermal management. The focusing lenses required manufacturing precision measured in microns, any imperfection potentially causing catastrophic failure. When the laser fired, yet automated production systems achieved this precision thousands of times daily. The exotic alloys used in the laser assembly came from supply chains as fragile as they were global, dependencies that military planners documented in reports about strategic vulnerabilities, while continuing to build weapons that required materials from countries that might become enemies. The command unit variants of the Assaultron line received enhanced sensor packages and communication equipment that allowed them to coordinate attacks by multiple robots, turning individual killing machines into networked forces that could execute complex tactical maneuvers. The stealth field technology integration presented the greatest challenge, the power requirements threatening to overwhelm the Assaultron's fusion core until engineers developed more efficient field generators that could cloak the unit for extended periods. These advances came too late for widespread deployment before the war ended, leaving warehouses full of standard Assaultrons, while a handful of stealth-capable units deployed to special operations forces who would mostly die in the nuclear exchange. The Liberty Prime Weapon Systems integration consumed resources that might have produced thousands of conventional combat robots. General Atomics engineers, justifying the expenditure by arguing that the psychological impact of a 100-foot robot hurling nuclear warheads would be worth any cost. The shoulder-mounted catapults required targeting computers sophisticated enough to calculate trajectories for projectiles that would arc through the atmosphere before descending on targets miles away. Ballistic algorithms that accounted for wind resistance and Earth's rotation, precision that seemed excessive. For weapons delivering nuclear payloads where proximity equaled accuracy. The eye lasers drew power from the same fusion reactors that animated the Colossus energy transfers measured in gigawatts, heat dissipation systems that glowed cherry red during firing sequences. The Mark II development phase attempted to address the power consumption issues that had plagued the Mark I, incorporating more efficient reactor designs and improved actuators that reduced the energy required for each step. The Commonwealth facility that manufactured Liberty Prime components operated under security so tight that workers required escorts to move between sections, their knowledge compartmentalized so that no individual could comprehend the full scope of what they were building. These precautions proved pointless when the bombs fell, the secrets they protected rendered irrelevant by the collapse of the civilization that would have used them. In the silence of abandoned factories where assembly lines still move, in the flicker of terminal screens preserving corporate hierarchies that mean nothing to wasteland scavengers, in the mechanical patrol routes of robots serving organizations that exist only in their programming, the legacy of RobCo Industries and General Atomics International persists. The robots they built outlasted the corporations that designed them, the nations that deployed them, and the world that needed them. Mechanical ghosts walking through ruins their creators never imagined, serving purposes their programming never anticipated, surviving in a wasteland that represents both the failure and the strange immortality of pre-war American innovation.